Okay, in this video we're going to kind of talk about how to go from two-dimensional Lewis structures to three-dimensional shapes. Now, since we're going to go for three-dimensional shapes, we're looking at molecular geometry, or this thing called VSEPR, VSEPR Theory. What does VSEPR stand for? VSEPR stands for valence shell electron pair repulsion. So what that means is that these lone pairs around the outer atoms and the central atom are going to start repelling against one another, and that's going to cause the outer atoms to bend out of a two-dimensional space possibly and give it a three-dimensional shape. Now, since we're going to be drawing three-dimensional shapes on two-dimensional plane, we're going to use some symbols to represent things that are not in the same plane as a central atom. So if you see a shaded in triangle, that is telling you that that outer atom is going towards you. If you see a dash, that's telling you that that the outer atom is in the same plane as the central atom. And if you see dashes, that means that the outer atom is going away from you. Now, the shapes that we can possibly have, and I have a handout for you. It's in the PDF form on Canvas, and when we come back, I will give you a physical copy so you can have that and use that to figure things out. But here are the shapes that we can possibly have. If we have two things coming off of the central atom, more than likely our shape is going to be linear. And the bond angle for a linear shape is 180 degrees because it's a straight line. We can also have, if we have three things coming off of our central atom, we can have a trigonal planar, and the bond angle is 120 degrees for a trigonal planar. Another shape is bent or angular. In this one we do have two things, but on this one, this is kind of telling us that the central atom is going to have some lone pairs on it. Another shape is called tetrahedral. Tetrahedral, we have four things coming off the central atom, and the bond angle for a tetrahedral is 109.5 degrees. So let me kind of show you these shapes real quickly. So our linear shape, okay, so central atom, two outer atoms in a nice straight line. Trigonal planar. Let's see. Make one for you real quickly. Okay, here is trigonal planar. So it makes a triangle that's in the same plane as the central atom. Bent. And tetrahedral. So now if you kind of look at the way that I drew the tetrahedral shape. So X is our central atom. We have one outer atom in the same plane going up, one coming out towards you, and two going away. So if we look at this one, it's kind of set up like this. Now on the paper, they draw it like so. So they have two outer atoms in the same plane, one coming towards you, one going away. Sometimes when we draw these, it's a frame of reference. However you're looking at it, might be drawn just a little bit differently. Okay, so we keep on going. All right, so trigonal pyramidal, trigonal base pyramid, And our bond angles in trigonal pyramidal is less than 109.5 degrees. We can have trigonal bipyramidal. This is two square-based pyramids back to back. So we have bond angle of 90 degrees and also a bond angle of 120 degrees, and I'll show you that to you here in a little bit with the models. We have a seesaw and we have a T-shape. So trigonal pyramidal, kind of look like this. Okay, or we can turn it like this, where one is in the same plane, one's coming towards you, one's going away. Kind of hard to see right now. Trigonal bipyramidal is this one right here. So if we kind of look down from the top, all right, so here's our triangle-based pyramid. One's facing north, one's facing south. So bond angle, 90 degrees between north and south to the central axis. And on our central axis, here's 120 degrees from here. Seesaw, that T-shape, really hard to draw these. Okay. Okay, now, last three shapes to talk about. Octahedral. In an octahedral, we have 6 things coming off our central atom, and we get 2 square-based pyramids, one pointing north, one pointing south, and all the bond angles are 90 degrees. Square pyramidal is a square-based pyramid. From the 4 points, it would be a less than 90-degree bond angle. Now, from the outer atom pointing northward and to the base, that is still 9 degrees. And we get square planar, where everything is going to be 90 degrees. So here is an octahedral shape. So everything is 90 degrees. Square pyramidal, so a square-based pyramid. Square planar. Now, the way that I drew the square planar on the paper is that we got 2 atoms coming out towards you, 2 going away. So it would look like this. Now, if we had an overhead view of square planar, then we can kind of see the outer atoms being in the same plane as the central atom. All right, so let's kind of look at some examples. Now this goes through. Now I'm going to do this pretty quickly. All right, so our first one is CH4. Okay, so there's the Lewis structure for CH4. Single bond going from the carbon to each 4 of the hydrogen atoms. Now, this is my Lewis. Figuring out our VSEPR shape. So we have 4 things coming off of it. So we look at this handout and we start with the leftmost column and we look to see what shape has 4 things coming off of it. Well, that would be tetrahedral. So CH4 VSEPR shape, tetrahedral. We can draw it like that. Or we can draw it like this. It's the same thing. All right, now let's move on to NH3. These are ones that we've already done so far, so check your notes. So our Lewis structure for NH3 was this. Single bond going from the hydrogens to the nitrogen, and then we have a lone pair. So now, going to the VSEPR. Now, how many things do we have coming off the central atom? Well, we got 3 hydrogens, and we have 1 lone pair. So we still have 4 things coming off the central atom. Well, on the handout, we still go to the leftmost column. What shape has four things coming off of it? Tetrahedral. But now in this situation, since one of the things that is coming off the central atom is a lone pair, we need to move one spot to the right. Okay? So the VSEPR shape is not going to be tetrahedral for NH3, it's going to be trigonopyramidal. So that's my VSEPR shape. Okay, IF5. So we have 5 fluorines and 1 lone pair on the iodine, our lowest shape. So we have a grand total of 6 things coming off of the iodine. So the shape that has 6 things coming off of it in the leftmost column is octahedral. One of those things is a lone pair, so we got to move one spot to the right, and our VSEPR shape for IF5 is going to be square pyramidal. Now the reason why, if we have any lone pairs on the central atom, why do we have to move away from the leftmost column? With VSEPR shapes, we do not show any lone pairs on the central atom. They're still there, but we don't show them when we draw out the shape. We're just showing atoms. Okay, so let's go on to our next one, XeCl4. Okay, and this one, xenon has 2 lone pairs. So we have 4 chlorines, 2 lone pairs. We start with the octahedral, and since we have 2 lone pairs, we've got to move 2 spots to the right. That takes us to square planar. So VSEPR shape for XeCl4. Square planar. Okay, CH3SH. This is kind of like one of the last ones that we did last week. Now, this one, sulfur, is going to have 2 lone pairs. Now we have 2 central atoms in this one. We have the carbon and we have the sulfur. And if we look at the carbon has 4 things coming off of it, the 3 hydrogens and the sulfur. So its shape, if we can kind of start drawing it, since it's 4 things, and none of them are lone pairs, is going to be tetrahedral. Now the sulfur, we has 4 things. It has the carbon, the hydrogen, and 2 lone pairs. So that would be tetrahedral to start off with, but since we have 2 lone pairs, the VSEPR shape for the sulfur is going to be bent. So that's what we're going to draw there. Now our last one, SO2. I'll make sure I get 18, 4, so 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Then we're going to take a lone pair off of one of the oxygens so we can make a double bond with sulfur in that oxygen. All right, so now if we look, how many things do we have coming off of it? We have 2 oxygens. 1, 2, then we have a lone pair on sulfur. So the shape that has 3 things coming off it is trigonal-planar. But since one of the things that we have coming off the central atom is a lone pair, the VSEPR shape is going to be bent. So that is the VSEPR shape for SO2. Okay, so watch this video, try to take some notes along with it. Have any questions, email me. We're going to go over this more when I see you next. So thank you for watching.